Hello, everybody. Welcome. This is iLight Robotics presenting how to create PCBs using EasyEDA. My name is Matthew Gallagher, and I'm joined with.
I'm Katie Gallagher.
Hello, I'm Akshita Ramesh.
We are all members of the iLight Electronics sub-team centered in Haymarket, Virginia, and we're going to talk about some PCBs. So I'm going to hand it off to Katie to talk about what a PCB is.
Thank you, Matthew. So PCB stands for printed circuit board, and they are boards of lines and pads that allow various points to be connected to route power and signal. They're typically made with copper and plated with a substrate that insulates the PCB. This is typically epoxy resin and glass fiber, and the substrate is then carved away to expose the design of the PCB. So PCBs are used both in and out of FRC. Inside FRC, they help save a lot of space and weight, which is obviously very important, and they can also help with a lot of the organization aspects of your robot. Some examples of what they can be used for is CAN hubs, ultrasonic sensors, canifiers, and a lot more. Outside of FRC, PCBs are used in almost every electronic appliance. They're used in computers, TVs, cell phones, and even some microwaves. And now I'm going to hand it off to Akshita to talk about CAN.
Thank you, Katie. So what is CAN? CAN stands for Controller Area Network. And the purpose of CAN is to connect different points together so that they can all exchange information with one another. In the real world, CAN is used in all vehicles, industrial machinery, and many other widely used technologies to interconnect the systems of the device together so that they can work in unison. In FRC, CAN can be used in order to connect motor controllers and other devices together so that they can communicate between one another. CAN is usually connected in topologies. Three of the main topologies are star, ring, and daisy chain topology, and the picture below entails the daisy chain topology. When using CAN in FRC, we can use CAN hubs to allow communication between different components in a device to be faster and easier. Using a daisy chain topology consists of linking all of your CAN devices together in a chain. And while it can be used and while it can work efficiently, it isn't always the best option. You can also look into using a star topology, which consists of linking all of your CAN devices to a middle entity, in this case, the CAN hub, and each device has equal access to communication with the others. An example of the star topology can be seen below. And while the star topology can allow communication to be easier, there's also a downside to the star topology. Wires in a star topology are limited in length to about a foot to avoid problems with communication, as over longer lengths of wire, the signal can get disrupted. So now we can pass it over to Matthew to talk about EasyEDA basics.
Thank you. So as we said earlier, EasyEDA is a program that we can use to design schematics and PCBs that we can later print using some company to gain a custom circuit board. So EasyEDA is just a URL that you can go to. To log in or create an account, you're going to go to a screen that looks something like this. You can continue with Google to create an account that way, or you can click register now and create an account otherwise. I'm not going to do that now because I've already done that, and we're going to jump over to the EasyEDA main menu. So once you've finally logged into EasyEDA, this is what it's going to take you to. Now before we get into making PCBs and schematics and all that, I want to talk a little bit about some of the features EasyEDA possesses. My personal favorite is the Teams function. So if we hover over our user icon and click User Center, let it load, it's going to take us to our projects, but most importantly, we want to look at this Teams here. Now, a team is exactly what it sounds like. It's a place that you can manage projects amongst several people, typically an FRC team, to share and collaborate ideas and designs. To create a team, you can click Create a Team Now, or click the little plus in the top left. You can type in your team name, And this team path will be automatically generated based on the team name. You don't have to worry about that. And finally, you can add a team introduction, which is just, it's non-mandatory, it's just a little description of what your team does. Now, if you've been using EasyEDA for a while and you already have people that you want to join your team added as friends, you can add those members here. Otherwise, you can do that later. And then you would create team to create team. Obviously, again, I'm not going to do that because I don't need to right now. And now let's go look at the online editor. So there's two ways to navigate to the online editor. You can hover over product and click online editor, or if you're back at that main screen, you can hover over products once again and hit online editor. This is going to be where you do the majority of your work within EasyEDA. You can also download the client by clicking it right here, which just gives you an executable file on your computer that serves the exact same purpose as the online version. There's very little difference between it. It's all up to personal preference. And finally, to create a new project, which we'll talk about in a moment, you're going to use this little document file, but I will let Akshita do that. But before we do that, we're going to go back to our presentation and talk a little bit about what a schematic and a PCB are, because I've been throwing that word around a little bit. So this picture you see here is a very complicated PCB. It's got connections, components everywhere. If you were to show this to even a highly trained professional, they would have no idea what it does. This is what a PCB looks like. This is a schematic. A schematic is a simplified version of a PCB, typically separated into its main components, and it's meant to make a PCB much more user-friendly and easy to understand. And to show you how to create your first schematic, I'm going to hand it off to Akshita.
Thank you, Matt. So first off, we can just start off with a new schematic. So here's EasyEDA. To get to the online designer, just click this button. And we'll let it load. Now we'll start up by designing our first circuit. So click New Project, and then you can name your project. We'll name this one LED Circuit Tutorial. And then you can also describe it, anything you want. So then here's your canvas. If you right click, you can move around, and I'm gonna zoom in. So first things first, you're gonna need your power source. So go to EELib, and then we're gonna use this power source. So just place one down. And then after that, you're gonna need a resistor. We're gonna use a European style resistor because the measurements are better than the American ones on here. And then lastly, you're gonna need your actual LED. So just look up LED, and we've got one here, and then just line it up. So now you've got all your components, now you've got to wire them. So go to wiring tools and click the wire, and then just connect everything together. To get those 90-degree angles that you're really looking for in a circuit, you have to just basically click down once, and then it'll create that 90-degree angle. So just continue connecting your circuit together. And ta-da! You have an almost finished circuit. Now you have a finished circuit. So many times when you're creating your circuits, you're going to have many different designs on one file. So to separate that, you can just draw a rectangle right around it. And this one, we're going to make it a dashed line rectangle. And then you can also label yours using this little label text tool. And I'm just going to label this LED circuit. And now you've got your circuit ready to become a PCB. But before you do that, remember to save. So now this is saved. And if you click this little drop-down menu here, and you click Convert to PCB. Ta-da! Here's your PCB. You got your LED, you got your resistor, and you got your power source. Now I'll turn it back over to Matt to talk about net ports.
Thank you. So now that you've created your first circuit, you should have something that's looking along the lines of what I have here. And we're going to talk a little bit about this thing, what's called a net port. Now, a net port is, in layman's terms, a little marker that's going to connect different components of your circuit without actually drawing the wire. There's two types of net ports. There's the ones that you can grab from over here, which are meant for just your typical connections. And then there's the ones that you can find in the EELib library called the ground flag and the voltage flag. Now we're going to take this design that you just did with Akshita, we're going to remove the power source and we're going to replace it with our voltage and ground. So we're going to click it and then click delete on both the connections and the power source. And let's grab a 5-volt marker as well as a ground marker. We'll use space to rotate it. We have those added in. And now, just like last time, we're going to grab our wiring tool and connect everything. And there you go. Now you've created the exact same circuit, but now if you were to print this as your own PCB, you would have to solder in your own voltage and ground. Now we're going to go ahead and save that. I'm going to do Control S. You're going to see it's going to, loading, successfully saved. So we're going to convert it to PCB again, and now you see a new dialog. It's saying you got some unfinished nets. Do you want to check the nets first? What this is doing is if you had a large circuit with a bunch of net ports, it's going to check are there connections? Are there any connections that are just random that don't really need to be there? We're just going to ignore that for now just because all we have is a 5-volt and a ground. We'll hit no. And you can see our PCB got significantly smaller. And we'll see actually if we zoom in close enough, that little ground and 5-volt marker are where we put them. So we'll go ahead and move those into our little bitty PCB. Move the label so it fits. We can use space once more to rotate things. And then this blue line is defining where we need to make connections within the PCB. So just like when we were doing the schematic, we'll grab our track and we'll make that connection. And there you go, you've completed your second PCB. Now, PCBs have a little bit more complexity, and to talk about a PCB's layers, I'm going to hand it off to Katie.
Thank you. So PCBs can have a lot of different layers to work on when things are getting a little bit too complicated to do on just one level. You can create connections both above and below each other using what's called a multi-layered PCB. And this is done by using a series of holes, or vias as they're called in EasyEDA, to transition from layer to layer. So we're going to come on over to EasyEDA, where I have something similar to what you should have made with Matthew using the net ports. And I'm going to work on making a multi-layered LED. So I'm going to bring another LED in here and just place it beneath where our first one was. And then I'm going to connect this up to the other wires. And what I'm also doing here is I'm anchoring it on the side, which is just making it look a little bit nicer. And as you see, when the wires are connected like that, there will be this big red dot that shows up that just makes sure that, so that you can see where the connection is. So I'm going to create a dashed box around this. And then we're going to save and come over just like they've shown you and convert to PCB. I'm just going to keep going since we still only have the two net ports. So here we have the purple box with all of your pieces in it. So we're going to pull everything up again. And if we need to, we can make this purple box a little bit bigger, because not everything is fitting perfectly in it. And as you'll see, there are these blue lines, and the blue lines need to be connected. Sorry, it looks weird. All these blue lines need to be connected by the time when you're finished with your PCB. So we're going to come up and grab the track and just connect both of the LEDs. So we also need to bring this second LED up to the resistor. So we're going to tap right in the middle, but as you see, these tracks can't cross. So we're just going to stop it there and grab this little tool up here, which is the via, and then put it there and on the other side of the track that we're trying to cross. So now we're going to come back in with the track from that second via that we placed and connect it to the resistor. And now you have your multi-layered PCB. So I'm going to pass it back over to Matthew to talk about CAN hubs.
Thank you. So on screen now, you're going to see a couple IDs and codes for some parts and components we're going to need to build our CAN hub. These first three here, the IDs are codes that you would use typically to search on different websites like DigiKey to actually find the real life components and then order them for when you get the PCB to actually install. And this last one I'll talk about in just a moment. But I'll go over each ID here real quick. So the 311 is going to be your surface resistor. This is going to be your 120 ohm resistor that terminates the signal. The CKN is going to be your switch, which when turned on or off determines if the CAN hub is your terminating component. And then the 277 is going to be your green wire housing, where you plug in and use the CAN wires to the actual hub. All of these IDs will be in the description of the video, but let's talk a little bit about this one here real quick. This is a part ID within EasyEDA, so go ahead and copy that down, and that's going to get us the schematic in PCB part to actually add in this very tiny terminating resistor. So go ahead, take a moment, write that down. I already have it on copy paste, so I will give you guys a moment. Alright, and now let's go back over to EasyEDA. So to start off, like last time, we're going to create a new project. We'll call this Final CAN Hub, and we'll click Save. So we have an empty schematic, which we should all be familiar with by now. We'll zoom in, go over to our ELIB, and we're going to start off by grabbing one of these connectors. It's the top right one over or underneath the connectors subcategory. It looks a little something like a rectangle. I don't know how else to describe it. We're going to use space to rotate it. We'll get rid of that really long and pointless ID. And this is going to be where we add in all our green wire plugs to actually add in the CAN wires. And we're going to create the input part of the circuit. So as everyone should know by now, CAN works on low or high signal runs. So instead of 2 or 1, we're going to do, that's supposed to be an L. Oh, I have caps lock on, that's why. L, H, and then we're going to use some net ports. So we'll grab one net port and then 2. And we'll label these high and load. We'll move them so they're readable. And then we gotta connect them to the little connector. And there we go. We've created the first third of our CAN hub. We'll put a little box around it, make it dashed, and then add a input label. So now let's move on to the terminating resistor part of the circuit. I'll do that over here. So the terminating resistor is going to be the only part of the circuit that is bridging low and high. So we'll start off with two net ports. We'll label this one high and keep the other one low. And then you guys should have that ID from just a minute ago. I'm going to paste that into this little search bar, press enter, and you can see it comes up with only one result. So once you click on it, it's going to give you typically 2 to 3 pictures. We're getting lucky with a third picture. The first picture is what the component's going to look like within a schematic. The second, what it looks like within a PCB. And the third is what it looks like in real life. So we'll go ahead and hit place. We'll put that in here. I think we need to slide that down. And then we need to add in our resistor. Oh, I forgot. I could just grab it right here. So we're going to change that 1 kilo to 120 ohms. We'll get rid of that really long label again. And then we're going to bridge everything together. And there we go. We have our switch and resistor all in here. Let's grab our rectangle. We'll put that over top. Make it dashed. And then we'll label this one the terminating resistor. So now let's get to the thicket of the part where all the CAN connections come in and out. So to connect it to everything else, like we've done twice now, we should get 2 net ports. We'll label the top one low, and then let's grab a connector, and we'll move it all down here. Get rid of that long label. Just like last time, change the 2 to an L, the 1 to an H. Then go ahead and bridge those together. Now, currently we only have 2 different connections for CAN, so that's kind of a pointless hub. Let's get another one. Get rid of the long label. Gets a little tedious. Same thing. And now let's connect the low and high to their respective parts. So now we have 3. If we want to add more, we can hold Control and select everything. Do Control C, Control V, and we've added in another one. And you're free to add in as many connections as you want. For video purposes, I'm only going to do a couple. So once that's finished, we're going to create another rectangle over everything, make it dashed, and then add in a label. There we go. That's the entire schematic for a CAN hub. Before we convert it to PCB, we gotta save it. So we'll do a little Control S. We'll go to Convert to PCB. And here we are. This is what it's gonna look like when we're making the PCB. So let's make this purple border a little bit bigger by grabbing the edges and dragging it. I personally prefer having the switch in the middle, but that's all up to preference. So move that there. We'll put this up here. It's important to, well, there's 2 important parts of moving all the components to your respective places on the circuit. 1, make sure your connections go low, high, low, high, low, high, or else whenever you're gonna follow whatever pattern you like of green on the left or green on the right, if you make an error and don't flip these correctly, it's going to suddenly switch in your PCB from green on the left to green on the right. And then secondly, the other important part is to know the dimensions of whatever you're adding to your PCB. Obviously, I know I'm soldering something relatively large to this, so I can't have the connection ports right up against each other. It's not going to fit. So it's important just to spread them out So I won't do all of the connections on here, but we'll go ahead and follow some of the blue lines. And this part really is easy. You're just following any connection you see. So sometimes it's going to tell you multiple things need to connect to the switch. In reality, you only need one of these to connect to the switch as long as they're all in a chain. So let's go ahead and we'll make this the last one. So let's connect the low to the low. And getting a similar issue to when Katie was telling you about vias, we can't really cross over here, and it's going to look really gross if we go all the way around. So let's bring it out to here. We'll stop it there, grab a via, and then let's go edit the bottom layer. You can see the silk layer, or the yellow, disappear or gets darker. We'll bring this layer over a little. We'll go back to the top, add a via, and then finish off the connection. And there we go, we've chained two together. I'll go ahead and do one more real quick, and then I think after that you guys should be able to follow the pattern. So since we did low on top, we'll keep that same pattern of doing low on the top, and then we'll bring high over here. We'll put a V on it. We'll go edit the bottom. We'll bring this connection over here. Grab a via. Put it there. And there we go. We have a second connection. Now, since I'm trying to do this a little quickly for video's sake, I'm obviously not putting as much effort into making the connections look organized and uniform. I do highly recommend that if you do this yourself, you do show the uniform connections between everything, just so when you're looking at this PCB in the future, you know what's going on. But I think that's all I'm going to do for now. Once you're done, obviously, you can do a little Control S. And we'll go back to the presentation, and then in a moment, I'll show you how to export this little design and actually make it into a real PCB. So here's a quick little sneak peek. This is iLight's CAN hub. Little trivia, this was the second CAN hub that I ever designed. The first one had a few issues that we had to fix. That's why I'm telling you, make sure you have all the components rotated in the right orientation. But you can see that the connections are a lot more uniform, and it is a lot nicer to keep those uniform connections for when you're looking back at it. If you want to, go ahead, take a photo. This is a very efficient design, very space efficient as well. But let's talk about exporting our PCB. So we use a service called OSH Park, or I think it's OSHA Park or something. OSH Park is a service that you can use to order the PCBs you've designed within any PCB design application. We just use EasyEDA. There's a ton of designing applications as well as PCB manufacturers. These are just the ones that we prefer. Excuse me, I haven't had water in a while. So let's learn how to export a PCB. So I'm going to go back over to this older PCB just because it has all the connections finished. And once you're done and you've saved your file like I just did, you're going to go, where is it? Right here. So under the document folder, you'll click the drop down arrow, and then it's going to say generate PCB fabrication file, also known as a gerber. Favorite word in the English language. I don't think it's technically English, but a gerber file is basically the instructions that the company will give the PCB designing machine to actually create your PCB. If you've ever used a 3D printer, it's very similar to the G-code file. And once you are about to generate it, it's going to ask you, do you want to create a DRC? The DRC is just going to tell you a little bit about your PCB, like how much it might cost. You could just ignore that. So we'll hit no. It kind of does it anyway, but not as much. And then you'll see generate gerber. You click that, and it's going to give you a zip file with the Gerber file within it. And then you can go to OSH Park's website and say, upload Gerber, order this amount of that PCB. And then finally, we're going to end the video with a little challenge. Now, the CAN hub that we showed you how to design today is a star topology CAN hub, where each connection only goes out to a single device a single time without ever having a reciprocating connection. Now, daisy chain is typically known to go from one component to another, but what we're challenging you guys to do is create a CAN hub that uses daisy chain topology. We did a little bit of an AutoCAD sketch up here, and you can see that the CAN connection starts in the RoboRio, comes out to the CAN hub, and with one connection goes out to a SparkMax, and then loops through several different SparkMaxes before coming back to the hub and continuing with the next SparkMaxes. So, this is my challenge. Create your very own daisy chain hub. We created one for our 2020 robot, and we found it very helpful. Anyways, thank you so much for tuning in, and goodbye.